All right, here we are for chapter 10, vocabulary. We got about 21 or 22 words, so let's go ahead and get started. We've got circle. Definition of a circle, the set of all points in a plane that are equidistant from a given point. That given point is your center point of the circle. A word that we should be familiar with is a radius, a segment whose end points are the center and any point on the circle. So as long as it's one of the points is the center and the other endpoint is on the circle, it will always be a radius. A chord is a segment whose endpoints are on the circle. So a chord, as long as it's got one endpoint on the circle and the other endpoint is on a circle, that is a chord. So it's a segment because it has a starting point and a stopping point. And as long as it's anywhere starting point on one side of the circle and the stopping point is another part of the circle. And a type of chord is the one that you've been familiar with and you've learned about in the past. That's a diameter. A diameter is also a chord because it's got a starting point and a stopping point on a circle, on the edge of the circle. But it's a diameter because it also contains the center, the center of the circle. And that makes it the diameter. All right, let's do a secant. It's a line, not a segment, a line that intersects a circle in 2 points. All right, so we can extend this out and make sure it's got your arrows on both sides. And as long as it's a line with arrows on both sides, that's your secant. So you can adjust it anywhere as long as it intersects a circle in 2 different points. 2 different points. And as soon as the secant is only intersecting the circle at one point, it becomes a tangent. Tangent is a line in the plane of the circle that intersects the circle at exactly one point. So as soon as it only intersects at one point, it is no longer a secant, it is now a tangent. So we have a secant, 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 secant. Now we have a tangent. 1 point. And at 1 point, where the secant and the circle intersect, that is called your point of tangency. So that 1 point where they intersect is your point of tangency. All right. Moving on. We have concentric circles. All right. Concentric circles are coplanar circles that have a common center. Excuse me 1 second. So as long as these circles have a common center, so here's our first circle we have. I'll make another circle that has the same center. These are concentric circles. They all share the exact same center. All right. Now we're going to check out what a central angle is. An angle whose vertex is the center of a circle. So as long as you got the vertex at the center of the circle, you have a central angle. So this angle right here is called a central angle. It's in the center. Oops. It is in the center of the circle, central angle. And notice what it creates. All right, so we've got the central angle. All right, and this is also a central angle here. All right. What happens is these angles, these central angles, all right, they create these things called arcs. And an arc is created from the endpoints that are on the circle. We've got an arc right here. And there's several types of arcs. We have a minor arc, whose arc measure is less than 180, a major arc, whose arc measure is greater than 180, and we have a semicircle. It's also an arc, and the measure of that is exactly 180. So this red arc right here, that would be a minor arc. The green arc, oops, this green arc going all the way around, I'll try to make it nice and neat, is a major arc because it is greater than 180 degrees. And if we were just to specifically do a semicircle, right, a semicircle is created from a diameter, and that is exactly 180 degrees all the way around, half of the circle. All right. We also have types of angles other than a central angle in a circle. One of them is called an inscribed angle. An inscribed angle is in as in inside the circle. It's an angle whose vertex is on the circle and whose sides contain chords of a circle. All right, so the vertex is on a circle and the side are chords. So there's a chord. Here is another chord. And we have an inscribed angle. The vertex is on the circle. All right, and we also have an intercepted arc. And an intercepted arc is the arc that lies between the two lines of rays or segments. All right, so this right here specifically is the intercepted arc of the inscribed angle. All right, so these can extend out and be rays, or they can be lines. But this part right here, this is the intercepted arc. Intercepted arc. So I'm going to copy and paste this over here to talk about those words subtend. So if the endpoints of a chord or arc lie on the sides of an inscribed angle, the chord or arc is said to subtend the angle. So for example, this arc right here, this red arc, it subtends this angle right here. All right. Another way you could say these is this angle right here that we have, it intercepts this arc. This angle intercepts the arc, but this arc subtends this angle. All right, let's talk about a circumscribed circle. The circumscribed circle is a circle that contains all the vertices of an inscribed polygon. So if you've got a circle and you've got a triangle inside that circle, and all of the endpoints or the vertices of that polygon or the triangle, all right, this is called a circumscribed circle. Circumscribed circle. It also works with a quadrilateral. All right, still a circumscribed circle. Every vertice is on the circle. All right. If you're still with us and still paying attention, for some extra credit, and don't tell anybody, just do this design around circumscribed angle. Make like a cloud around that. You can get a little extra credit. So, circumscribed angle, an angle whose sides are tangent to a circle. It's an angle whose sides are tangent to a circle. So we've got another, take this circle. All right. So tangent means that you can only touch the circle at one point. All right. And we'll go right here. So this angle we just made is right there. That's a circumscribed angle. Circumscribed angle because these two lines here are tangent to the circle. So the angle whose sides are tangent to the circle. All right, and now we're gonna close to finishing up. Segments of a chord. The segments formed from two chords that intersect on the interior of a circle. So the segments form from two chords that intersect on the interior of a circle. So we've got two chords inside the circle. And notice that they intersect. These segments that are formed right there, and right there, and right there, and right there are called segments of a chord. Those are called the segments of a chord. All right. We also have a tangent segment. That is a segment that is tangent to a circle at an end point. So there's got to be an end point. So up here we've had this tangent goes on. This tangent line can't go on forever in both directions if it wants. A tangent segment has to have a starting point and a stopping point. So here we have a starting point and a stopping point. This is a tangent segment right here. There we go. And the secant segment is very similar. Also is a segment that contains a chord of a circle that has exactly one endpoint outside the circle. So you've got to have a secant. Touches it at two spots, 1, 2, starting point and a stopping point. So this is a secant segment because it's a starting point and a stopping point. This is a tangent segment, starting point, stopping point. Tangent only touches at one point. Circle touches, or excuse me, secant touches the circle at 2 points. All right. And finally, we have the external segment, which is part of our secant segment. The external segment is the part of the secant segment that's outside the circle. So this part right here, that is our external segment. So this whole thing is my secant segment. All right, the part outside would be the external segment. All right, and that's all we got for you.